on Wednesday, I gave you guys the rectangle quiz, and I'm just gonna go ahead and just read the description. So I did grade this, and I took off points here and there from students just because they didn't completely follow all the instructions. So it tells you to create a class named rectangle that has floating point instance data for length, width, and then create getters and setters for length and width. Constructors for the rectangle should accept data for length and width. Create a method to calculate and return the rectangle's perimeter. Create a method to calculate and return the rectangle's area. Override the toString method to return a string that represents the object. And then I tell you to create a driver class that instantiates a rectangle object and test all of its methods. So you should actually have called all the methods, including the set. And then I asked to think about how you would filter data for the setters for length and width. And that was more along the lines of, okay, well, we're having these setters, right? There's the whole idea of encapsulation is to prevent your data from being sent to something that doesn't make sense. So for length or width, what do you think a good filter would be for your length and your width? Like what data you think would be considered bad or does not make sense for a length or width? Sorry, what's that? Negative numbers, right? So you want to check to make sure that the data is actually greater than 0, probably. Maybe even a 0 wouldn't make sense, right? Because they're like, what's a 0 dimension of, like nobody says, oh, this is 0 inches or 0 feet, right? So anything greater than 0, I would say, would be what you would want to allow. All right, so I'm going to get started on this. All right, so I'm creating my Java file rectangle, and I'm going to go ahead and write the class. So I'm going to say public class rectangle, open close curly braces, and then the instance data that I tell you to have, if you go back to the quiz, is I want you to do floating point for a length or a width. So it's up to you to determine if you want to use a double or float. I'm going to go ahead and use a float. So I'm going to say private float length and width. Okay, so I do also tell you to create getters and setters for length and width. So I'm going to go ahead and do that. So I'm going to say public void set length, and then I'm going to take in some float value. I'm going to say that length is equal to the value that is passed in, and then I'm going to do the same thing for width, but I'm going to cheat here. I'm just going to copy this, paste it. All right, and then I'm going to say set width. And width will be equal to the value that is passed in. I'm going to go ahead and make the getters. So I'm going to say public. The getter returns the value, so the value that we're going to return is a float. So I'm going to say float get length. And then I'm going to make the getter for the width. All right, now what I'm going to do is, well, I'm going to go back to the quiz before I continue, just to kind of follow along with what I'm doing here. So create a rectangle that has floating point instance data for length and width, then create the getters and setters for length and width, which I just did. Now create a constructor for the rectangle, which accepts a length and a width. So I'm going to go ahead and make my constructor. So the name of the constructor, it needs to match the name of your class. Name of your class needs to match the name of your file. So my constructor will have the visibility modifier, which is going to be public, and then the name of the class, rectangle. Okay, now
What is this called again? The constructor?
constructor, yeah, this is called the constructor, which is the method that is called when your object is instantiated. Also note that there is no return type on the constructor. So I'm going to go ahead and take in a float, and I'm going to just say like length. I'm going to do len, and then a float, and wid. And then I'm going to say that length is going to be equal to the length value that is passed in, and then width is going to be equal to, width is going to be equal to the width value that is passed in. Okay, any questions so far?
I got a question.
Yeah.
So what's the difference between what you just did and then those getters and setters? 'Cause it looks like it's like kind of the same thing.
It does look, okay, so the question that was asked was, what's the difference between the constructor and the getters and setters? So the constructor is always called when you first instantiate your object. So whenever we specify a constructor, this particular constructor, we're saying, in order for me to make a rectangle object, you have to pass me a length and a width before that object is instantiated and put into memory. Okay? So before you actually make that object, you're going to need a length and a width. Now, if I did not have a constructor, does anybody know what happens if I don't have a constructor? Anybody remember what happens when you don't have a constructor? Nope.
Your program will start yelling at you.
Actually, it won't yell at you. Okay, so like not having a constructor is okay. It just means that there's no steps that you need to take in order to set up your object. So I'm going to go ahead and leave it like this for now. I'm going to go ahead and write my rectangle test. So I'm going to come over here, make new, and then I'm going to save this as rectangle test. So public class so this is the driver class, so it is going to have the main method. All right, so inside of my driver class, I'm going to instantiate a rectangle. All right, now because I did not specify a constructor, okay, Java will automatically have a constructor for my class where the constructor does not take any value. So whenever I instantiate an object, I need to use the new and then the name of the constructor, which is the name of the class. And because I didn't specify a constructor, then this constructor doesn't take any values inside of it. And from here, I can go ahead and use my object. I can do things like, okay, well, if I just instantiated this object, I'm curious to know what is the length of this rectangle, what is the width of this rectangle. So I'm going to say width of the rectangle, and I'm going to say rect.get width. And then for the length, I'll print that out as well, just so that I know. All right, so now I'm gonna go ahead and compile this. All right, so remember, if all I have to do is compile my rectangle test, and because my rectangle test is using rectangle, it's going to compile both rectangle test and rectangle. So I'm going to say Java C rectangle test dot Java. And I already messed up. Let me see, rectangle test. Oh, I misspelled my class right here. So the name of the file has to match the name of the class. Okay, I'm gonna change that, and I'm gonna hop over here, recompile. Everything compiles. So I'm gonna go ahead and run. So Java, then the name of the class that I want to run. As you can see that my width and my length are both 0. So we just said that 0 does not make sense for something that you can take measurements on, right? Like, how do you have a 0 length or a 0 width? Right? That just means it doesn't exist at all. So why do you even need a rectangle object if both the length and the width are 0? Is there really a rectangle if it doesn't have any dimensions? Right. Okay, so because I decided that I did not want to include a constructor right here, then Java just automatically made one which doesn't do anything. And since I didn't do anything inside of my constructor, length and width were just initialized to be 0. Okay, so to me, it's bad to have, measurements that are 0. So in this case, what I'm gonna do, I'm gonna have to rewrite this whole thing. All right, maybe I can do Control Z. Or Control Z. All right, so I do want to actually create a constructor that says, okay, if you want a rectangle, I'm going to expect you to give me a length and a width, okay? And those values are going to be passed in right here. And then whatever values you give me, I'm going to go ahead and assign those values to my length and my width, okay? So
when someone does give you those values, how would that look? Are you getting to that point?
yeah, I'm going to get to that point. Okay, so now when I try to compile my rectangle test, Java's telling me, hey, there's no constructor that takes in there's no constructor for rectangle that takes in no parameters. It only found a constructor that takes in a float and a float. Okay, so understanding the errors that you get back from the compiler is like half the battle, right? I came over here, I added a constructor that takes in 2 floats, but if you look at my rectangle test, I'm still trying to use a constructor that takes in no values, right? When I went to go compile, Java told me exactly what was wrong. So I'm gonna come over here, and now when I create my rectangle, I'm gonna have to give it values that, or values that make sense, or I guess I don't necessarily have to give it values that make sense, but at this point, I do have to give it 2 values, one for the length and one for the width. And I'm going to go ahead and do that, 7.5 and 6.7. And now when I go to compile, my rectangle test does compile. And then when I go to run, right, there's my output for my get width and my get length. Okay, any questions so far? All right, so this could still be negative and 0, which also doesn't make sense. So I'm gonna go over there and change it, compile, run, and you can see that my length of my rectangle, my width of my rectangle are 2 values that don't really make sense for something that you take measurements on. Now, unfortunately, we haven't gotten to chapter 5 or 6, so like knowing how to correct this problem isn't really like something that I'm going to require you to know. But if you did want to correct this problem, what you can do is you can, like, after you've taken the second Java class, you can throw an exception if the values don't make sense. Or another thing you can do is see if the values are within your range, right, of 1 through or greater than 0 or above. But if it's not, then what value you're going to put there, right? I don't know. I mean, you can default it to 1. It's all up to you. But at this point, we're just not going to worry about it for now. But if you did decide to create some type of filter, you could come to your set length and say, okay, well, I'm only going to set the value if the value is greater than 0. And then and only then will I set my length. Right? And then you can do the same thing with your width. And then here you can just call your set length and pass in the length. And then your set width, passing the width, and then like an additional step. I mean, like if you, because you're constructing this object, so you're passing in these values, even though you are filtering them out, the value is going to remain 0 because the data that came in was still not greater than 0. So if I come over here, clear my screen, recompile, and run, I have 0 and 0 because the data that came in here got filtered out, and then Java just decided to make this 0, right? So then you can take one last step to say, okay, well, if my length is still 0, then what you can say is set my length to, I don't know, we'll just say like 0.001 f. It's up to you. I mean, like this is where you're the programmer. You decide like how you want your program to behave. Oops. In this case, I'll set my width to the same value. So now I'll hop over here, compile, run. And since I got a bad value in the constructor, I decided to just put like something there, right? 0.001. Maybe you might want to put a 1. I don't know. It's up to you. It doesn't matter. I mean, just you wanted something other than 0. It doesn't matter. As a programmer, you would have to make that decision. Okay. Now, like I said, all this is chapter 5 and 6 stuff. It's all good to know, but for now, let's just stay focused on staying within what we know, so that you're more prepared for the midterm instead of being confused on using if statements and things like that. All right, so that is the difference between the constructor and the getters and setters. The constructor is always called when your object is first instantiated. All right, any other questions on this before I continue? Okay, so one of the things you were also supposed to do is use your getters and your setters. So I did use my getter. Now I'm going to come over here and say, okay, well, I want to change the width and the length of my rectangle to something different. So I'm going to say set length, and I'll just say like negative, or actually let's make it something valid. We'll just say like 9.123 f. And then we'll set the rectangle width. And then we'll print out our values. Okay, so all I'm demonstrating here is I use my constructor to construct my object. I print out my width and my length. Then I modify my length and my width with my setters. And then I print out my length and my width. And I hop over here, compile, run, and you can see that the values changed after I called my setter. All right, I'm going to hop back to the quiz description. So I effectively have completed everything there. Now the next thing it tells me to do is create a method to calculate and return the perimeter, create a method to calculate and return the area. So like I said, I'm going to say this again because I did see some mistakes on the quizzes that were turned in, is that you should not have instance data for anything that is calculated, right? So I should not have an area up here or a perimeter up here, because those values are dependent on length and width. Whenever length and width do change via the setter, you're going to have to go and update your area and your perimeter. So for anything that is dependent on something else, you can just make an on-demand method that you can use to calculate and return that value. So here I'm going to make a method called public float area. And what this is going to do is give me the area of my rectangle. The area of my rectangle is equal to my length times my width. Okay, I'm going to make another method called perimeter. Returns a float. And then the perimeter is equal to 2 times my length plus 2 times my width, or my length plus my width plus my length plus my width. It all depends on what you want to use. I'll just go ahead and use my length plus my width plus my length plus my width. Right, because you're just getting the measurement of the outside of the rectangle. And I have those two methods working. I want to go ahead and test to make sure these are actually working correctly. So I'm going to come over here and I'm going to change my setter to something that I can calculate just by looking at. So I'm going to make my length 4 and my width 5. And then I'm going to display the area and the perimeter. All right, so I'm going to come over here, clear my screen, compile, run, and you can see that my width is 5 and my length is 4. So my area should be 5 times 4, which is 20, right? And that's what my area is. And then the perimeter of this rectangle would be 5 plus 5, which is 10, plus 4 plus 4, which would be 18. Right? So these this calculation is actually valid. So you should always call your methods to make sure you're actually getting valid values. So you're testing also to make sure your calculation is correct. All right, so let's hop back over to the quiz. The next thing I tell you is to override the toString method and to return a string that represents the object in some way. So why do I say override? Well, like, what does that mean? Exactly right. So overriding just means that there is a method on an underlining class that already exists. So the toString method actually already exists on this rectangle, but it doesn't give us data that we are considering is something that's informational to what we're actually doing. So if I come over here and say system out println, I just say result of toString method. So there's two ways to get the toString method. You can either invoke it directly. So I can say rectangle or rec.toString, right? Call that method. Or I can just concatenate the object to a string, and the toString method is automatically called by Java. So I'm going to go ahead and just do them both so that you can see that they both do the same thing. So I'm going to go ahead and compile, run, and you can see that in both cases we get the same thing. We get rectangle at and then some hexadecimal value. So this is actually invoked on the underlining object class. So every class that we create inherits from a class called object, which is a generic class in Java. And the toString method is a method that is available on the object class. So when we say override, that just means we're going to create our own version of the toString method. Okay, and just another thing that you should probably know is there's also an equals method that is on the object, and we'll talk more about this in chapters 5 and 6. So we can check to see if one rectangle equals the other, or a rectangle equals some other object. I can just come over here and say taco, right? And I can say the result of equals is equals method. And hop over here, compile, and run, and you can see the result of equals method is false. Now, the object's underlining equals method is just really just comparing to see if the two objects are the same object in memory. So this is a point to where I can create an alias, right? I can come over here and say, okay, well, I have rectangle, and I have rect, and I have rect2, and I'm going to say rect2 is equal to rect. Now, what this is doing is not actually copying the data over twice. Like, remember, these are actually object reference variables, so they're both, so this one's pointing to some object in memory. Now, this variable is pointing to the same object that rect is pointing to. So they're both pointing to the exact same object in memory. So if I come over here and say, well, does rect equal rect2? And we'll see that the result of this is going to be true. And you can see now the equals method returns true. Now those are methods that are available on the underlining object class. If I wanted to modify them so that they can serve a purpose for me, like a more detailed purpose for me, I have to come over here and override them. If you look, I do not have a toString defined, and I do not have an equals method defined. So I'm going to hop over here, and I'm going to override the toString method by saying public string toString, and then I'm going to return a string that is going to have more information and be more valuable to me than what the current toString method does, which is tell me the rectangle and then like this hex value. Okay, so I'm gonna come over here. I'm gonna say, okay, well, things I want to know about my rectangle is the class and the value of the width and the length. So I'm gonna say length is some value and width is some value. Then I'm going to come right in here and I'm going to concatenate in my length and come right here and concatenate in my width. All right, so now when I go back to command prompt and compile and run, you can see that I have a more meaningful toString method that actually gives me this current state of my object. All right, any questions on this? So in chapter 9, I believe, whenever you get to your second part of the Java class, they talk more about inheritance. But for now, what you need to know is you need a toString method, or you need to find a toString method. Otherwise, it's just going to use the underlining objects class toString method. So in all the homework and everything I ever give you in this class, I'm always going to ask you to make a toString method. So it's just it's basically a method that returns a string and gives you like a snapshot of what the state of the object is. Here it's giving me the length and the width of this rectangle. And the name of the method is toString. If I wanted to override the equals, I can do the exact same thing. I can say public boolean equals and then have it take in some object, and then I compare them, determine if they're equal to each other. But we'll talk more about that in chapter 5 and 6. All right, and that's it. That was the quiz. I did say to make a driver class that tests all of the methods of the rectangle. If you look at my driver class, I do in fact call my setters, my getters, and the area and perimeter, and I even call the toString method. Any questions on this? Okay, so this is what you have to do for this is what I'm expecting when I ask you to write a class. This is what you have to do for your homework as well. Yeah.
The other thing, you can go back, not the driver class, but the rectangle class.
Okay, so just to kind of no, I mean, like, but this is a good learning point too. There's several types of classes. Okay, we have the driver class, which is the main method. So if you remember, the class with the main method is the entry point for your program. Whenever you compile and run your program, whenever you run your program, your JRE is going to look for your main method and it's going to start your program. So that's why we call this a driver class. This class over here, this is what we call a blueprint for an object, right? It's just basically telling Java how a rectangle object should behave, right? You can have other classes that we haven't talked about yet. You can have classes that just have utility methods. So they're like util classes that aren't used to instantiate an object, but they're just used to hold methods that you can call to do some type of work. All right. Anyway, sorry about that. Well, what was your question?
So the blueprint area. So I get the whole construction, the constructor, but whenever you start setting length and setting width, like whenever you say return length and return width, I don't understand. Like whenever you put the float and then val, is it always going to be val like in parentheses?
No. This is data that is. This is what we call our parameter list, right? So the name of these variables in your parameter list are just temporary placeholders. So this is just me telling Java, I expect a float. As long as this is any valid Java identifier, then we're okay, right? So I can just write any valid Java identifier That is a valid Java identifier, believe it or not. Okay. Now this means that val does not exist anymore. If I were to go over here and compile, you're going to see that it cannot find symbol. Cannot find symbol means this value here doesn't exist to Java. It's like, where the heck is it? I don't see it anywhere. And that's because we changed the name in a parameter list to be this other valid Java identifier. So that means I have to set length equal to that value.
So that makes
Dang it.
sense.
I thought I copied this.
What does that do then? Like, how does that? I just don't see.
This is a blueprint, right? So by me defining this method, I'm telling Java, okay, I want a set length method that takes in a float, and whenever I get that float in, I'm gonna set length equal to that float. Okay. I mean, we could take more steps, like we did before, where we check to see if the value is valid, but in this case we didn't, right? So we're just telling Java, we're defining a method called set length, and we're going to take in a float, and whenever the value comes in, we're going to assign that value equal to my length.
And that's how we get it.
Right. So if I come over to what am I doing? Come over to my driver class. Here's my set length. I pass in a 4. So that means Java's going to hop over here and say, okay, well, what does set length do with the 4? Oh, okay, well, I'm going to put my 4 right here. And now what's highlighted, or what was highlighted, is where my 4 is at, right? 4 is passing here, 4 is there. Now 4 is now your new length because that value was copied over to your length instance data. Previously, right, length was some other value. Length was negative 7.5. Right, so if I come over here and compile and run, you can see that, oh shoot. You can see that length was negative 7.5, but after I called my setter, length is now 4 because I passed in a 4 to my set length. Right, so this is the blueprint. This is me telling Java how a rectangle object behaves. What's the values it's going to retain? Yeah. Any questions? Any other questions on that? All right. So let's go ahead and do another example. So let's see. From the book or from the homework, there is, I don't know, there's several ones from the book. So which problem from the book do you guys want me to do from your homework? I'll do one right now. Just like type it all out. I'm not gonna put it in Dropbox though. So you're gonna have to either watch this video when I post it or keep up with me as I type it.
Let's see, boss man. Hardest one.
Okay, the hardest one is probably the die class one, I guess. Well, not really, but I did the die object for you, but there is a class called pair of dice that manages 2 die objects. And students get super confused on it because you're actually going to need 3 files, right? But I think I would rather not do that one just because I like students to struggle on that one. You know, like, because you don't learn unless you struggle, right? Like, we all learn from our mistakes. Like, if I just tell you what the answer is, then you
pick them up and throw them in the deep end of the pool.
Exactly. I taught my son how to drown like that. All right, so I'll look through. Let's see. I'm gonna do you show me the box one, right, with the Boolean. I'm gonna do the box one. I'm gonna go ahead and read this. Okay, so all right, this is what it says. 4.6 from the homework says to write a class called box that contains instance data that represents the height and the width and the depth of the box. Also include a Boolean variable called full as instance data that represents whether the box is full or not. Define the box constructor to accept and initialize the height, width, and depth of the box each newly created box is empty. So basically what you're going to do is you're going to take the length, the width, and the depth inside of your box, but you're going to set full to false inside of your constructor. And then let's see, so each include a getter and setter method for all instance data. That also means the full instance data. And then create a driver class that that creates several box objects and tester methods. All right, this is actually like really easy, very similar to what we just did. All we're doing is adding a third dimension, length, width, and depth, and then we're going to add in a Boolean variable for if it's full or not. All right, so I'm going to go ahead and just type this up really quick. I'm going to hop over here, go to New, Files, Save As. I'm going to save this to my desktop and not to Dropbox. So the name of this class is called Box. And I'm going to save it as a Java source file. I'm going to come over here and say, okay, well, public class box. And per the instructions, I need instance data for the length, width, and depth. Okay? And then I also need instance data called full, which is going to represent whether the box is full or not. It said that the constructor should take in values for length, width, and depth. So I'm going to say I need a float for length, I need a float for width, and I need a float for depth. Okay, so then I'm going to say length is equal to that, and width is going to be equal to, width is going to be equal to the width that's passed in, and depth is going to be equal to the depth that is passed in. And then it says to initialize the box to be empty. So in my constructor, I just taken the length, taken the width, taken the depth, and then set full to false. Okay. Then I'm going to create the getters and setters, right? I'm not going to do that just because it's just a lot of typing. Well, maybe I'll do, dang it. I don't have to, but, and because I'm already setting all this data, but the one that I do want to do is the getter and setter for the full, because it's a Boolean, and it's super confusing to us because we haven't used a Boolean instance data just yet, right? So the other one's traditional get set, just like over here in the rectangle where I have set length and set width, right? And then get length, get width. Length, width, depth is going to be exactly like that. It's just what we call boilerplate code. It's just code that we just type over and over again because of the way we defined our class, right? That's what we call boilerplate code. It's just you write a instance data, then you need a getter and setter. You go and make your getter and setter based off the type of data that your instance data is. But we haven't done anything for the box. Now this is the part where you kind of have to, maybe you have to like kind of use your own discretion on how you want your object to actually behave. Okay, so if you're just kind of following the pattern of what we've done in the past, then it is perfectly okay to make a getter and setter that look like this. Public void set full, and then you take in a Boolean value, right? We'll just say F, and we'll say full is equal to whatever value that is being passed in. And then your getter would be public Boolean get full, and then you're going to return whether or not this box is full or not. So I'm going to return full. Okay, and then I'm going to make my toString public string to string. All right, and then I'm going to return a string that represents my object in some way. I'm going to go ahead and use string.format. I used it a few times. I like to use it because I can make my string the way that I want it, and then I can just inject my data. So I'm going to say box, and then I'm going to say length is a floating point value, and then width is a floating point value, and depth is a floating point value. Okay, and the last thing was whether it's full or not, and that is a boolean. I believe the boolean is just %b, and then I'm going to inject my data by just putting in the values that I'm going to pass to this method, and that is length, width, depth, and full. Okay, now this method is on the string class. It's static, meaning you don't need a string object to invoke it. You just use the name of the string class and then format, and then you can just put a string here, and the percents are where you want to inject your data. So the first %f is going to be my first float. The next one's my second float. The next one's my third float. The last thing is my Boolean value, and it's going to be either true or false, right? And I just pass the values into the parameters. I do not test you on knowing string.format. I just use it a lot because it makes my life simpler. Okay, you can just make a string and concatenate in all the values like we were doing before, but at some point you're going to have to learn new things on your own. I suggest to learn how to use string.format. It makes your life a lot easier when you're trying to type out a string a certain way. All right, so now that I have my box, I'm going to go ahead and make my box test. So I'm going to hop over here and save this class as box test. And this is a Java file. All right, so I'm going to say public class box test, and then public static void main string array arguments, and then inside of my constructor, or excuse me, instead of my main method, I'm going to create my box object. I'm going to say box, and I'll just say box1 is equal to new box, and I'll just say dimensions for this box is I don't know, 12 by 10 by 7. All right, and then I'm going to just do a system.println and print out my object. And the way I print my object out is call its toString method by just passing the object to my system.println. The toString method is automatically called. I just kind of want to see what this object looks like after I constructed it. So I'm gonna hop over here. I'm going to clear my screen, and I need to change directory to my desktop. So I'm gonna say cd, and then where am I at? And then a couple more, and then go to my desktop and do Java C box test.java, and it compiled. So now I'm going to go and run box test. All right, and then there's my values. Okay, so there's my length, there's my width, my depth, and whether it's full or not. Then I'm going to go ahead and change this. I'm going to say, okay, well, I want to change whether the box is full. I want to go ahead and fill it up. So I'm going to just call the method is box full, and I'm going to call get. Let me see. So I'm going to say box1 dot get full. It's going to tell me if my box is full, and then I'm going to say something like system.out.println, and I'm just going to say filling box. Okay, and I'm going to invoke the method box1 dot set full, and I'm just going to say, okay, well, just set full to be true. And now I'm going to just print out the state of my box, and then I'll print out my object one more time. So I'm going to have another toString method. All right, I'm going to go ahead and make a new line like right here, and yeah, that should be good. Okay, so now let's look at what I did. Instantiated my object, printed out my object, then I just invoked is full, which is going to return false because I had not actually did anything to change the state of my box. But then I'm saying filling box, and then that's when I call set full, and then I print out if the box is full or not. Again, I ask the question, is the box full? And then I am going to get some value. This time I'm going to get true. The only reason I know I'm getting true is because right here I passed true to set full. That means whatever it was before, which it was false, is now set to true. So I'm going to come over here, clear my screen, compile, run, and now you can see I call is box full, false, filling box. Now the box is full, and then I just call my toString, and you can see all the values in my toString. Okay, any questions on that? It's pretty simple. I mean, I know it seems like a lot of tedious work to make instance data and then write getters and setters, but really that's all we're missing here is the rest of my getters and setters and we have the toString, we have the constructor. I mean, a lot of this is just repetitive boilerplate code over and over and over again, but over here is where we actually instantiate what we created and then just call the methods. All right, now there is another thing I want to talk about the Boolean. Okay, so whenever we call get full, a lot of times in the industry, it's always a better practice to ask a question that you get a true or false back on, right? So get full might not, seems kind of weird when you say it, I guess, right? We should ask a question like, is full, right? If you want to be more technical with it, you can say, is the box full, right? But for now, let's stick with is full, okay? Now, typically we do get and set whenever we make our instance data, but when it comes to Boolean values, people tend to kind of write method names that make a little more sense. So instead of using get full, this case we use is full. That means if I come over here, I'm gonna just, instead of using get full here, I will have to use is full, and here I would use is full. It doesn't actually change anything, right? Like everything's still the same, but it just changes the way we call our method, right? And it might make a little more sense to say call a method called is full instead of calling a method get full. Another thing that you can do that some people like to do, okay, since there's only really two states of full, whether it's true or false, instead of using a setter where you take in a value, you can just do something like, okay, well, instead of using a setter, I'm going to say public void and then say something like fill box. And then a fill box would just set full to true. And then another thing you can do is public void empty box. And then you would say full is equal to false, right? Or, yeah, okay? So you can do getter and setter like that, okay? Where you have two setters. And now if you want to fill the box, instead of saying set full here and passing a true, you just say, okay, well, fill box. And you don't pass a true or false. You just invoke the method fill box. Come over here, compile, run, and it works exactly the same, except that I changed the services I provided on the box. Now instead of taking in a Boolean value, you just tell me if you want the box full or empty. Okay. You do also have a light bulb one or light switch where it tells you. It doesn't actually tell you what type of data to use, but you can make a bulb. I'll go ahead and read you what it says here. This is 4.2. So 4.2 tells you to write a class called bulb that represents a light bulb that can be turned on or off. Create a driver class called lights whose main method instantiates and turns on some bulb objects, right? So for that one, you can just have instance data for on, right? If it's on or not on, right? So if on, if it's true, that means it's on. If it's false, it's set to false. Your getter for that one would probably be like is on, and then you just return on, right? But if you wanted to stick to the traditional way, you can just do get on. Your setter would be turn off, right? You just set on to false, and the other setter would be turn on, where you set on to true. I know some people like to use strings for that one. There's nothing wrong with using strings because it did not actually tell you what type of data to use. But on the bulb class, I personally feel that this more simple way of doing it would just to use a Boolean value as your instance data, whether the light is on or off, instead of taking in a string, because a string can be a numerous amount of possibilities. Right, anybody can pass in any string. So a light being on or off is either true or false. Right, any questions on this? It's pretty simple, right? I mean, I know it's a lot. If it feels like a lot to you, then you're not programming enough, right? Open your book to chapter 4 and just start trying to knock these out. And by the end of chapter 4, like, you're going to get that pattern down, name of your class, your instance data. You need getters and setters for your instance data. You need a toString, and you need to make a constructor that does something specific, right? A lot of chapter 4 does, I mean, I know it seems complicated because it's something different than what we've been doing for the past 4 or 5 weeks, but a lot of it is just repetitive. Okay? All right, so let's do another example, 730. Okay, so, all right, let's think of a new object. Actually, maybe I'll give you guys something to do. Let's see, counter, clicker. All right, so that's all in your homework. I'm gonna stop doing homework questions because I want you guys to actually do the homework questions. All right, let's see. I'm gonna go ahead and give you a quiz, and I'll just kind of start it for you, and then you guys can finish it. So let's hop over here, and we'll make this quiz number 6.
For the midterm, sir,
Yeah.
is that necessary?
What do you mean? Oh. All right, so let's write a class. Let's think about something that we can write. I mean, you can write an object for anything if you just think about it, right? We represent anything in a program. Everything has states and behavior. So when you're thinking about a state and a behavior, you have to decide what instance data are you going to use, right, to determine the state of the object, right? So like a car, I mean, if you just think about a vehicle, right? So a vehicle will have obvious stuff like the make and the model, right? But then it'll have other things like how many wheels does it have, and I mean, you can get into a lot of detail, but depending on what your program you're writing, right, you might not need all that detail. Okay, so those are things that you need to think about. I can't really think of an example of what I want you guys to do. I need something that has a method that isn't a getter or setter that you have to just call in order to perform some type of behavior. Okay, so let's go ahead and write a class for, I don't know, dang it. I wish I would have thought of all this before I showed up to class.
Study, write a class to study.
Yeah, let's do the student one.
Just saying study.
Okay. Did we already do student? I don't know if we did. The demo one was a student? Okay. Yeah. I don't know. Now, the only thing I can think of is a something that we interact with every day. Okay, let's just do. What? One of the examples I gave in the discussions was a fork, I believe. I can't remember. But we'll say write a class for a fork. Okay. So what type of instance data do you think a fork will have? A length of a fork?
Yeah,
I mean, there's always a length, a width. I mean, but you think that's important to, what's that color? Yeah, the material. We'll say
the length of the spike.
okay, instance data for the material, meaning if it's plastic or metal, right, or I don't know, wood, right? There can be several types of material. Then also maybe like the number of prongs, right? Num of prongs, right? So like some forks have like 3, some have,
My fork has 4.
well, most have 4, but I guess,
A spork? You get a spork?
yeah, there's
So are we gonna generate a fork, or is it,
what do you mean generate a fork?
because forks can come in prongs of 3 to 4.
Right, so the instance data is gonna be information that you take into your constructor, right? So when they instantiate a fork, you're writing the blueprint, right? So you as a programmer are deciding what's the instance data for this fork that I'm gonna use. This might be a fork for some fork factory that's kind of keeping track of all the different types of forks it has in its database, or this might be like a fork in a video game that there's plenty of forks laying around the entire video game that somebody has to pick up and use to eat something, right? Depending on like the situation, the instance data is going to be different in each case. So for instance, a fork in a video game is going to have like the color and like the model that you're going to use for that, like all that would be like instance data that you would include. A fork for a factory or a store would like include a price, right? Because you're trying to keep track of inventory and stuff like that. So you would want a price and maybe like the company that you bought it from. But in this case, like we're just trying to just make something not too complex, right? But I do want at least 3 things that we can use for our fork. So we're gonna say material, number of prongs, and then like the color. Okay. Now I'm gonna leave up to you like what data type each one of the instance data is gonna be. Material is probably gonna have to be a string, right? The color, you could actually use, there is a class called color in Java that you can use, but it's probably better if we just use the string class for that. Number of prongs should probably be an integer, right? Or some type of integer data, because that is a number. So we have instance data for material, number of prongs, color. I'm going to say create getters and setters for all instance data. Okay. And also create a toString method that returns a string that represents all right, and then some other things that we're going to do is create a constructor. All right, and then create a driver class create a driver class that instantiates all right, so here's what we have. So write a class for a fork that has instance data for material, number of prongs, and color. Create getters and setters for all instance data. Create a toString method that returns a string that represents the object in some way. Then create a constructor that accepts and initializes the instance data. So you're gonna have to take in 3 values: the material, the number of prongs, and the color. And think that is it. Unless somebody has something they want to add to this.
Yeah, backspace,
Backspace.
Control All, Control A, B.
All right, so. All right, so I'm gonna go ahead and like just kind of start this. All right, so the name of the class is Fork. So I'm gonna come over here and in Dropbox, dang it, what the hell, where Dropbox now? I can't, it's not in my recents. All right. So fork and all right. So I mean, we can do the obvious, right? Public class fork. All right, that was pretty straightforward. All right, now you have to think about your instance data. We said there's 3 things for instance data. We said we wanted material. We wanted num of prongs and color. Okay, so we're going to say that each one of these things are different. I should have put each one of these on a different line. Okay, so material, num of prongs, and color. All right, so these instance data is traditionally always private, right? Otherwise, you violate the rules of encapsulation. So private string, and then there's my material. And then for the prongs, I mean, that is definitely some type of numeric value that is a whole number. So we'll just say int for now. And then for color, for now we'll just say string, but there is actually a class called color in Java. I mean, if you guys are super motivated and want to learn new things, you can look that up. But for now, we'll just say string. And then you're going to have a constructor. But the name of your constructor has to match the name of your class. So in your constructor, you're going to have a parameter list that takes parameters right there.
How would that look?
And I've done so many examples, and everybody has a book or should have a book. Like, I want you guys to kind of figure that out, right? Midterms like in a week, so just kind of keep that in mind. And then from here, you're just going to initialize your data based on what is passed in, right? So your material is going to equal something, your number of prongs is going to equal to something that was passed in, and then your color is going to equal to something that was passed in. All right, and then down here, you have all your getters and setters, right? Getters and setters are based off of your instance data. So if there's 3, that means you're going to have 2 for each instance data, 1 getter, 1 setter. So you're going to have 6 methods right here. And then the last thing would be to create a toString right here, right? That returns a string that represents the object in some way. Okay? So that's how you get started. By this point, you should be comfortable with just taking anything and starting a class that you're going to use as a blueprint for an object. All right, so that's how you get started. Any questions on this? It's pretty straightforward. It's actually not that difficult because I'm not really asking you to create an additional method, but make a constructor, right? And then do your getters and setters, your toString, and then just make a driver class that creates a fork and calls all the methods on it. Okay, so that is all I have for now. You're free to go and do this at home, but I am going to want you to do this by midnight. Actually, I'll give you, midnight. I want everybody to work on it. I'm going to go through everybody's work, and if they don't have anything in Dropbox by midnight, I'm going to give you 0, okay? Because I want everybody to work on we have midterms in a week. You can't be blowing stuff off anymore, right? So get something in by midnight. It doesn't have to be correct. I just want something in by midnight. When I look at it, I can look at it and say, okay, well, they're working on this. But before class on Wednesday, I am going to grade them. Like I normally show up like around 5. During that time before class, I'm actually going to grade it. So by that time, it needs to be 100% complete. right? But I want something in by midnight that shows that you actually made some type of attempt to create this class, not just what I wrote right here. All right, any questions? Okay, I'll stick around till, or 8:10, the other class comes in. I'll stick around till then. I'll be able to stick around and help people outside till about 8:30. Yeah, if you still have questions after 8:10.